Salam alaikum. Please, as you are watching, subscribe to my channel and make sure you share it with some of your friends. In our previous lecture, we discussed properties of matter. So today we are going to talk about movement of particles in matter. The movement of particles in matter. How do particles of matter move? Particles in solids, liquids, and gases. So the first one is one of the things we will discuss under movement of particles in matter is viscosity. We are going to discuss what viscosity is. Viscosity is the resistance to the flow of matter. Activity 1.11 is demonstrating viscosity in liquids. So you have been given materials here. We have these liquids: water, honey, oil, milk, and paraffin. Then we have a sphere, which is a steel ball, then ruler, a stopwatch, and cylinders. So as you have been given this, so you have to conduct an experiment and see the resistance to the flow of those liquids. Resistance to the flow of these liquids: water, honey, oil, milk, and propane. So now we are going to try to draw some of this and see if cylinders are filled with these liquids. If cylinders are filled with these liquids, so what will happen to the steel ball if it is put inside in the cylinders? A steel ball of the same size, the same mass. Okay, for a water, when you put a steel ball inside, so the resistance to the flow of that steel ball will be less, it will be lower. So a ball will easily move to the bottom of the water. It will easily move down. There is no high resistance inside, so it will just move easily to the bottom of this, because the particles here are not close to one another. They don't have that greatest cohesive force of attraction. So it allowed the steel ball to easily move, no resistance in the flow. So for milk, it will also have the same, but for milk, the resistance of the flow of the fluid is little bit higher compared to water, compared to the flow of water. So the ball will move into the liquid with a little resistance compared to water, That resistance inside is what we call viscosity. Why does water have less viscosity compared to milk, yet all of them are liquid? It's because of the thickness of the particles inside. Again, milk have fats and protein inside compared to water. Milk have fats and proteins inside compared to water. This makes milk to be thicker than water. Therefore, there will be higher viscosity compared to water. So the order goes in that direction. That is the order of the increasing in viscosity. Water has lower viscosity compared to milk, and milk have lower viscosity compared to oil. The same oil and for pens here is also having the one with the greatest or highest viscosity is honey. Honey has the highest viscosity. Because honey is thicker than the other liquids. If you put a steel ball in honey, it will move slowly. Downward with a high resistance. Okay, since we have understood that viscosity is the resistance to the flow of the fluid or particles. So we say that different liquids have different thickness, thus having different ability to flow. So the state of liquid being thick and sticky due to internal friction is what we call viscosity. The state of a liquid being thick and sticky due to internal friction is called viscosity. You see, when the liquid is having internal friction, we say that it is having what viscosity, because it is that friction that will resist the flow of a substance, that is put in liquid. So we say fluids resist motion or relative motion of immersed objects through them, as well as the motion of layers with the different velocities within them. When there is an object being immersed in fluids, so there will be that resistance. The resistance will be depending on the velocity of that object being immersed in the fluid. The sphere move faster in water and lowest in honey. You see, the sphere move faster in water because water have lowest viscosity, and it move the lowest in honey because honey is having greatest or highest viscosity, highest resistance to the flow. This shows that water has lowest viscosity compared to other liquids. You see, and it offers minimum resistance. Because it offers minimum resistance, then other substance can move easily in it. It has a minimum resistance to the motion of a sphere through it. Honey has the highest viscosity. Compared to other liquids. So you should know that water is the one having lowest resistance compared to other liquids. Honey have highest viscosity compared to other liquids. And B, viscosity is the resistance of the flow of particles in a matter, or it is the state of liquid being thick or sticky due to internal frictions. Let us come to diffusion. Diffusion is a process in which molecules of fluid spread from regions of higher concentration to the region of lower concentration. See? What is diffusion? Diffusion is the movement of particles from the region of high concentration to the region of low concentration. It is a movement of particles from the region of high concentration to the region of low concentration. So, when we look at this activity, we use potassium permanganate here and a glass of a container. So look here, this is the setup for that experiment. This one is the solution of potassium permanganate. This is the solution of potassium permanganate in the container. So when this solution is placed in the beaker, empty beaker like this, and that solution is already there in the container, so pour water in this beaker until the beaker is full, here. So you will observe that later, after some few minutes, the particles of potassium permanganate solution here will come out of the container, which will come out from the container and is spread throughout the liquid here, throughout this water. So that process where these particles move from the container to the beaker here is called diffusion. It is called diffusion. That process is known as diffusion. The color of solution of potassium permanganate rise up and spreads to the entire space occupied by water. You see, the particles here, or the color of potassium permanganate, has come out and is spread with the water, and is spread through the liquid, and that color will be observed in the beaker here, due to diffusion. So the spreading continues in such a way that the molecules of the solution move from the region of higher concentration to the region of lower concentration. This is diffusion in liquids. That is diffusion of particles in liquid. So particles moving from the region of higher concentration to the region of lower concentration. You need to know how to define diffusion, which is a movement of particles from the region of higher concentration to the region of lower concentration. The spreading will stop when the concentration of the solution of potassium permanganate is spread all over the fluid inside, the liquid inside. The particles in liquid diffuse from one point to all parts of the liquid. Diffusion in gases. So this one is to demonstrate diffusion in gases. Okay, when you have two gases in different gas jar, or two gas jars, so, and you separate the two gas jar by using a glass plate. So after you remove that glass plate between the two gas jars containing different gases, so if you remove that glass plate, the two gases will mix together. They will diffuse from one gas jar to another gas jar. So as the particles move to other gas jar, you will know there is process of diffusion taking place. So you can see here we have two gas jars, the one containing air and the one containing carbon dioxide. This gas jar here, what is inside here is carbon dioxide. So, and this one is containing air, molecules, and this one carbon dioxide gas. Okay, follow the steps there. Here are the steps. Okay, in these two gas jars, the gas jar B here contains this one here. What is that substance? So this one is a blue litmus paper, moist, which is moist. This one is moist, that means it is wet. So wet litmus paper. So what is the use of this one in this gas jar? The use of blue litmus paper here is to detect the presence of carbon dioxide later when this plate is removed. When glass plate is removed. You get that? So that is the use of litmus paper there. The blue litmus paper turn red. So it turn red in the gas jar containing carbon dioxide. The blue litmus paper turns red in the gas jar containing carbon dioxide. It remains blue in the other gas jar. This shows the presence of carbon dioxide. This shows the presence of carbon dioxide. So when the blue litmus paper turns red, it shows the presence of carbon dioxide. Okay, a blue litmus paper turns red in gas jar B. Why? Because the carbon dioxide diffused to the top. After this one here, this glass plate is removed. This one is removed. So the carbon dioxide gas here will move to gas jar B. It will move to gas jar B. And therefore, as it goes to gas jar B here, then it is going to react with a moist blue litmus paper, which will show that this one will now turn red, which will show the presence of carbon dioxide in this gas jar B. Gas jar B. As soon as a glass plate is removed, the dense molecules of carbon dioxide gas raise upwards and spread to the region of air of low density. So the molecules of two gases intermix with each other. The spreading continues until mixture acquires uniform density. Until the mixture acquire a uniform density. As the gases is spread through the two gas jars, so they will mix uniformly until they have the same density. The observation shows molecules in a gas move from a region of higher concentration to the region of lower concentration. This is diffusion in gases. So from that experiment shows that gas can move from one region to another, that is from the region of higher concentration to the region of lower concentration. In gas jar A there is higher concentration of carbon dioxide. Therefore it will move to gas jar B where there is lower concentration, while in the gas jar B here there is higher concentration of air molecules. Therefore the air molecules will move to gas jar B where there is lower concentration. That process is known as diffusion. In gases. Diffusion in gases take place more quickly than in liquids. So diffusion in gases is that higher because the particles of gases have the greatest distance between them. Therefore, they can easily move. They can easily move, and they have weak intermolecular forces which make them to flow easily. The molecules of gas move freely than those of a liquid. This process by which volatile substance, e.g. perfumes, is sprayed through a room even when air is perfectly still. So like perfume, when you spray it inside in the room, it will be smelled at every corner in short time because they can diffuse easily. They can diffuse easily. In a solid, molecules only vary to and fro in their fixed positions. For solids, the diffusion there is that not higher because the molecules vary at their fixed position. It is important to note that rate of diffusion of gases depend on its molecular weight. So the rate of diffusion of gases depend on their molecular weight. So it depends on the what? On the weight of the molecules. So the one with the higher weight can not diffuse faster than the one with the lower weight. You see that? Thus, if molecular weight of gas A is four times that of B, then gas A would diffuse at half the rate of B. Here it is meaning that if the weight of gas A is four times that of gas B, then gas A would diffuse at half rate of B. This is best explained by using Graham's law of diffusion. This is best explained by Graham's law of diffusion, which states that the rate of diffusion of a gas is inversely proportional to the square of the mass of its particles. Let's try to formulate this law of diffusion, Graham's law of diffusion, used by deriving this formula. So the law is saying the rate of diffusion of a gas is inversely proportional to the square root of the mass of its particles. Let's say Ra is rate of gas A. So the rate of gas A is inversely proportional to the square root of its molecular mass. Inversely means indirectly proportional. So which is just like this. Rate of gas A is inversely proportional to the square root of its molecular mass. Like that. So assuming we have other gas, which is gas B, the rate of gas B is inversely proportional to the square root of its molecular mass. So let's say this one is molecular mass of gas A and this is for gas B. So if we combine the two together, like to find the ratio of the two, so it will be R A divided by R B. Then we divide this one by this. Let's do it now. Don't forget this one is 1 out of root of MA and this one here is 1 out of root of MB. So that is RA, this one is RB. So R out of RB is equal to the rate of gas A, which is 1 divided by root of m A divided by, because here we are using the ratio, because of this division we are putting this one here, this division. So divided by 1 out of root of m B. You see? So now to change this division sign here, this division sign, so what do we do? So we find the reciprocal of this part, then we change this one to be multiplication. So okay, now since we can do that, let's try to get the multiplication of this. So this rate of gas A divided by rate of gas B is going to be equal to 1 out of root of m A, molecular mass of gas A, times root of m B, that is molecular mass of gas B, divided by 1. So this one will multiply this one here. This is going to be numerator and this is going to be denominator for the ratio of the two gases here. So now let us write it well here. Rate of gas A divided by rate of gas B is going to be equal to the square root of molecular mass of B divided by the square root of molecular mass of gas A. So this is referred to as Gram's law of diffusion, which says that the rate of diffusion of a gas is inversely proportional to the square root of its molecular mass. So here you got the formula here, the one we are driving. You see here. So rate A out of rate B is equal to root of MB out of MA. Because when you are dividing the two values having the square root, so you can give them one common root. That's why they are under one root here. Where RA is the rate of diffusion of the first gas, and RB is the rate of diffusion of the second gas. So, and M represents the molecular or molar mass of gas A, and B represents molar mass of gas B. So that is all about diffusion. So what you have to know about diffusion is the definition of diffusion and the Gram's law of diffusion. Don't forget of this. So let us come to osmosis. So osmosis is a movement of water molecules from the region of higher concentration to the region of lower concentration. So here is the experiment. So you are going to investigate osmosis in semi-permeable membrane. Okay, get to follow this activity. You will see here this one here as about osmosis. Osmosis is a process through which solvent solution such as water move through semi-permeable membrane into a solution. Osmosis can be described in terms of kinetic theory of matter. More massive molecules diffuse slower than less massive ones at similar temperature. This means that particles that have large size and mass, they diffuse slower than the particles having smaller size and mass. if we have this, let's try to draw something here. So this one here is having large particles here, large particles or atoms, and this atom have also greater mass compared to this one. The molecules are not large. The molecules also have small size and mass, small mass. So this is what is meant by this statement here. That is what is meant by this statement here. Massive molecules, more massive molecules, and less massive ones. So a good example of osmosis is when an egg is put in a sugar solution. When egg is put in a sugar solution, water molecules pass through a semi-permeable shell into egg. Sugar molecules that are larger don't pass through. So when you put egg in sugar solution, you will observe that water molecules will pass through semi-permeable shell into the egg. So that process where water molecules go into inside in the egg is what we refer to as osmosis. Osmosis is a process through which solvent solutions such as water move through a semi-permeable membrane into a solution, or it is a process by which water move from the region of higher concentration to the region of lower concentration. Thank you so much for watching this video. I hope you enjoyed. Please share the video, and if there is any question, you can put it down there. Comment. We are going to pay attention to it. So please support us by sharing our channel to your friends and other people who might not come across our channel. Thank you so much. We are here for you. God bless you. God bless South Sudan. South Sudan education first. Sharing is caring. Bye.